Today is 5th December 2023, and today we are starting deformation. And you have already started the same chapter in your school. So I am making formula sheet for deformation. And what is deformation? So you know that when you apply a force, consider on a spring, and this spring has a certain shape. But when you apply a force on a spring, then this force stretches its length and changes its length and shape. Then according to Hooke's law, extension is directly proportional with applied force. Down that definition. Extension is directly proportional to the applied force, but within limit of proportionality. What is the meaning of limit of proportionality? Then I'm going to explain. According to Hooke's law, when you apply a force on the spring, it changes its length, it produces extension, and sometimes we compress the spring. So, change of length, that is called extension. Extension is directly proportional to the applied force, but within limit of proportionality. Sir, what is the meaning of limit of proportionality? So I can explain you with this table. Consider we are applying force on a spring and it is its extension. No force, no extension. Consider 5 Newton force producing 2 centimeter extension, 10 Newton force producing 4 centimeter extension, 50 Newton force producing 6 centimeter extension. It means extension is directly proportional with applied force. But when I apply 20 Newton force, I am expecting extension should be 8 centimeter, but consider it is 8.2 centimeter. So extension is not remain directly proportional. Force increased 4 times, but extension increased more than 4 times. So this force up to which the force up to which extension remains directly proportional with applied force or spring obeys Hooke's law, then this force is called limit of proportionality. Limit of proportionality is the force up to which spring obeys Hooke's law. And if spring obeying Hooke's law, then the graph between force and extension be, uh, becomes a straight line. But after limit of proportionality, the graph no more remain a straight line, but it begins to curve. It begins to curve and it always turns towards the extension axis if it is a spring. So limit of proportionality is the point up to which spring obeys Hooke's law. The graph remains a straight line. Acha, if I further apply force, consider I am applying 25 Newton force, then extension becomes consider 9.6 centimeter, etc. So right now I am increasing force. Acha, if I decrease force, I mean it is increasing load. And now if I decrease load, consider I am decreasing load. Load is 25 Newton. I am changing force to 20 Newton. The reading remains same. If I decrease force to 15 Newton, reading remains same. If I decrease force to 10 Newton, reading remains same. So, if you are increasing load, then the graph is in this direction. And if you are decreasing load, then the same graph, same reading. But sometime we increased load so much. We increase load so much. When we decrease load, the same readings not appear on the screen. We are decreasing load, but the same reading not appearing. Consider I am decreasing load to 25 Newton. I am expecting extension will be 9.6, but consider it is 9.4. When the load is 20 Newton, I am expecting the extension will be 8.2, but it is consider 7.6. I am expecting at 50 Newton extension will be 6 Newton, but consider it is 5.3. It means extension is not same. Sometime we increased load on the spring so much, the spring deformed plastically. So it has crossed elastic limit. And after crossing is elastic limit, when you decrease load, then same readings not appear on the scale, and the graph is not coincident on the increasing load. When we are decreasing load, when we are decreasing load, the graph is not same. Then we call this point as elastic limit. So on the graph, there are two different points. Number one, sir, what is limit of proportionality? Sir, limit of proportionality is the point on the graph, or it is the force up to which spring obeys Hooke's law. Spring obeys Hooke's law and graph is a straight line. But what is elastic limit? Sir, elastic limit is the point on the graph after which when you decrease load, when you decrease load, graph does not follow increasing load graph. The graph of increasing load and the graph of decreasing load are different, then this point is called elastic limit. Abda Afra, can you explain what is the difference between limit of proportionality and elastic limit? Afra? Huh? Huh? Then the graph of increasing load and the graph of decreasing load no not remain same. When graph of increasing load is not coinciding with the graph of decreasing load, then it means we have crossed elastic limit. We have crossed elastic limit. And you can see when you remove totally force, when you remove total force, then the object did not return back to its original shape. Original shape means extension should be zero. But right now you can see the extension is not zero. You have decreased load to zero. The load is zero, but the extension is not zero. Why? Because the object has changed its shape plastically. When you cross elastic limit, when you cross elastic limit, then its deformation is called plastic deformation. So the graph of increasing load and graph of decreasing load not coincide after elastic limit. Okay, I am repeating this sentence again and again. But Anjum आपसे सुनूंगा मैं. What is elastic limit? Sir, when the graph of increasing load and the graph of decreasing load does not coincide. When the graph of increasing load and graph of decreasing load not coincide, then we have crossed elastic limit. However, what is the meaning of elastic limit, Afra? Sorry, what is the elastic limit, Anjum? But Anjum, what is elastic limit? Elastic, हाँ, जब सेम नहीं बनता, अलग अलग बनने लगते हैं, तो इसका मतलब होता है कि हमने इलास्टिक लिमिट क्रॉस कर दी थी. ठीक है. एंड बिफोर इलास्टिक लिमिट द ग्राफ इज सेम. बिफोर इलास्टिक लिमिट द ग्राफ इज सेम, बट आफ्टर इलास्टिक लिमिट ग्राफ इज नॉट सेम. ओके, बेहतरीन. अच्छा बेटा, नाउ वी शुड मेक अ फार्मूला शीट. वी शुड मेक अ फार्मूला शीट. एंड फार्मूला शीट इज, नंबर वन, you should know Hooke's law. F equal to K E. E means extension. Number one. Number two, sir, if we draw graph between force and extension, then its gradient equal to spring constant. Number three, if you calculate, if you calculate area, if you calculate area under the graph, if you calculate area under the graph, then this area under the graph is called work done, work done on sample. It is known as elastic potential energy. It is known as elastic strain energy. But all these terms remain same up to limit of proportionality. अगर आप लिमिट ऑफ प्रोपोर्शनलिटी तक जो ग्राफ बन रहा है, इस ग्राफ का एरिया कैलकुलेट कर लो. देन एरिया up to limit of proportionality, then this area is called elastic potential energy, then this area is called elastic strain energy, then this area is called work done on sample, then this is known as work done on sample. Okay beta, have you noted? Beta, have you noted? But remember, after limit of proportionality, these three quantities will not remain same. After after limit of proportionality, then these a b c will not remain same. But right now, up to limit of proportionality, area means work done on sample, area means elastic potential energy, area means elastic strain energy. Okay. But after limit of proportionality, it will change. My statement will change after limit of proportionality. Okay. And after limit of proportionality, we exclude this c. After limit of proportionality, we cannot write elastic strain energy. We can write work done on sample, we can write elastic potential energy, but after limit of proportionality, we cannot write elastic strain energy. Okay, and I will explain you it further. But right now, which questions we are going to solve, these three quantities will remain same. After, have you noted these three formulas? F equal to K E. K is gradient and area means work done on sample. Area means elastic potential energy. Area means elastic strain energy. And its equation will be half force into extension or half K extension square. Half K extension square. Okay, beta? Acha, beta. Now I am writing three more formulas, and these formulas I will explain you in the next class. But right now I am writing only formula. Formula number 4, stress. But stress is force per unit area, and most of the questions area will be either pi r square or area will be pi d square upon 4. in most of the questions. And stress is denoted by this symbol. This is a symbol of stress. Number 5, strain. Sir, strain is extension per unit original length. Extension means extra length divided by original length. Extension per unit original length, it is called strain, and the symbol of strain is this. This is a symbol of strain. Number 6. Sir, what is Young modulus? So, beta note down, stress is directly proportional with strain, and the ratio between stress and strain, the ratio between stress and strain, it is called Young modulus. The ratio between stress and strain is Young modulus. And you know that stress is force per unit area and strain is extension per unit length. So this is the whole formula sheet of the chapter. If you memorize these six formulas, formula number 1, F equal to KE, number 2, gradient is spring constant, area is work done on sample up to limit of proportionality. Elastic potential energy is half Fe or half Ke square. Stress force divided by area. Strain extension divided by length. And the ratio between stress and strain, it is called Young modulus. And the value of Young modulus depends upon nature of material. Nature of material. The value of Young modulus for copper is different for steel, it is different for iron, etc. So, nature of material is expressed by Young modulus. So, I think you have noted this formula sheet. But Afra, have you noted? Okay, but and now we can start dangerous past paper questions. And first we are starting P2, and remember P2 is very simple. P2 is very simple, P1 is very difficult. Okay, but before starting this question, I should show another formula that is called resolving force vector. I am stating with a resolving force vector. Then we can solve that question. हाँ बेटा अंजुम, आपने ये पूरा टॉपिक पढ़ा हुआ है, आपने जब जुलाई अगस्त में ट्यूशन स्टार्ट की थी तो वी स्टडीड रिजॉल्विंग वेक्टर. ओके, बट आई हैव नॉट टॉट नंदनी, आई हैव नॉट टॉट अफरा. हाँ बेटा जरा फोकस कीजिएगा. कंसीडर this is a vector, this is a force F, and this force F is making angle theta. This force F is making angle theta. So we can resolve this force into two components. First one is a horizontal component and the other one is vertical component. Sir, horizontal component, how about a horizontal component of force is F cos theta. How about Nani, we are starting this topic. Note down formula. When a vector, when a force making angle theta, then it is resolved into two components. The first one, it is a horizontal component. अच्छा बेटा, आपको मेरी आवाज, नंदी को आवाज नहीं आ रही क्या बेटा? आप दोनों को मेरी आवाज आ रही है अफरा? अच्छा, अफरा को भी आ रही है. और बेटा अंजुम, आपको मेरी आवाज आ रही है? बेटा अंजुम, आपको मेरी आवाज आ रही है? अंजुम बेटा, आपको मेरी आवाज आ रही है? हाँ बेटा अफरा क्या करें ये तो। अफरा बेटा यू। ओके ओके। हाँ बेटा अंजुम। अच्छा अंजुम को भी आवाज आ रही है, यस सर, ठीक है बेटा। अंजुम बेटा आई हैव नोटेड। ओके। एंड आई थिंक देयर इज अ इशू फ्रॉम नंदनी साइड बेटा, बिकॉज अफरा। हाँ बेटा अब आपकी आवाज बिल्कुल साफ आ रही है मुझे भी। चलिए बेटा, ये बताइए नंदनी बेटा, जब मैंने ऊपर ये फॉर्मूला शीट लिखी थी, आपके क्लास में थी या दोबारा रिपीट करूं? Okay, beta. And now, before starting past paper question, I am giving you some knowledge about resolving force. And the topic is whenever a vector makes angle theta with x-axis, then this vector is resolved into two components. Its horizontal component is f cos theta. Its horizontal component is f cos theta. And its vertical component is f sin theta. If the vector making angle theta with x-axis, if the vector making angle theta with x-axis, then remember its horizontal component is f cos theta and its vertical component is f sin theta. Okay. And if you have noted this formula, then we can start past paper question. And the past paper question is here. Acha beta, we will solve this question at slow rate. We will not run fast because these are new questions for you. So the first part of the question is a wire hangs between two supports, a child swing, car tire, making angle 70 degree with horizontal, tension in the wire 150 Newton, and they are asking determine the weight of tire. Okay, determine the weight of tire. However, this is a vector question. It is not a deformation question. It is a vector question. And in vector, if I ask you to draw a horizontal line, and this horizontal line is x-axis. Okay. The tension in the wire is 150 Newton. The tension in the wire is 150 Newton. And this tension has two components. One component is horizontal component and the other one is vertical component. So this green line and as well as this blue line, I am drawing two arrows of different colors but of same size. These are vertical component of tension. The vertical component of tension is 150 Newton, making angle 17 degree. So its vertical component will be sine 17. It is green vector as well as this is blue vector. So the force is tension. Tension has two components. One component is horizontal, the other one is vertical. But this I am drawing only vertical component. So vertical component of green and vertical component of blue, it is of same magnitude. It is of same magnitude because both tension are 150. So vertical component and these vertical component are balancing the weight of the tire. The weight of the tire acting downward, the weight of the tire acting downward, weight of tire acting downward, and this weight is balanced by vertical component of tension. Vertical component of tension. It is one vertical component plus it is second vertical component. I am writing two times so that you can understand there are two strings, there are two tensions, so there are two vertical components of tension. The weight of tire acting downward, the weight of tire acting downward, and the vertical component of tensions. And there are two vertical components of tension, and these are acting upward. Okay. And now they are asking calculate weight. So I can write weight is equals to 2 150 sine 17. And now I am opening the calculator to solve it. But it is 2 multiply 150 multiply sine 17. So the answer is 87.71. So I can write 88 Newton. Okay, so it is the weight of the tire. So it is not a deformation question, it is a question of vectors in which the weight of tire acting downward and the weight of tire is balanced by vertical component of tension, and there are two tension forces in the string. So there are two vertical components of tension. The first one is 150 sine 17, the second one is 150 sine 17, and after adding these components the weight of the tire is 88 Newton. How beta Nandi, is it clear beta? Okay beta, it is not deformation question, and now they are asking calculate stress. It is very simple question. Calculate stress, and you know that stress equals to force per unit area. And in this question, force is tension of the wire, because in the wire the force is tension. In the wire the force is tension. So tension divided by area. Tension divided by area. Tension is given 150 Newton. Area is given 7.5 millimeter square. You know that milli means exponent minus 3, and it is millimeter square. It is millimeter square. So I'm solving 150 divided by 7.5 exponent minus 6. So it is the answer, and the answer is 2.0 exponent 7. 2.0 exponent 7 Pascal. It is, हाँ बेटा. Yes, yes, always, always. When you are stretching a wire, then the tension in the wire will be acting as a force. Okay, beta? No, no, actually, in this question, the strings are not vertical. The strings are making angle 17 degree with the horizontal. So whenever any kind of force making angle, we resolve this force. In the first part of the question, they are asking us just only what is the weight. So the weight of the tire is balanced by the vertical component of tensions. So I resolved tension into the vertical component, and by adding the vertical component of the two string, I calculate the value of weight. So weight equal to the vertical component of tension. It is the first part which is not actually about deformation chapter, but right now it is the deformation chapter, and they are asking calculate stress. And whenever they ask to calculate stress, then stress is force per unit area. And according to your question, sir, tension in the wire, tension in the spring, it will always act as a force. So to calculate stress, I am dividing tension by area. Tension is given 150, area is given 7.5. So the stress is 2 exponent 7. हाँ बेटा Afra, is it clear or not beta? And after calculating stress, they are asking calculate strain. And to calculate strain, we are given Young modulus. You are given Young modulus. And the value of Young modulus is 2.1 exponent 11. And now they are asking calculate strain. So you know that Young modulus equal to stress over strain. And if you have to calculate strain, then strain equal to stress we calculated 2 exponent 7 divided by Young modulus, and Young modulus is 2.1 exponent 11, and by dividing you can calculate strain. So it is very simple question. Have you noted? Acha beta, then question number 2 is dynamics question, and we have not studied dynamics, so how can I explain you kinematics graph or dynamics graph? So I am leaving this question, but this is pure deformation question, question number 3. However, question number 3 is a pure deformation question, and the first part of the question, define Young modulus. It is 1 mark question. Sir, Young modulus definition is the ratio between stress and strain. The ratio between stress and strain. It is known as Young modulus. And now this is a question. In this question, a metal rod is compressed. In this question, the metal rod is compressed. Okay. So it is being compressed, and now the question is calculate spring constant. Calculate spring constant. And we have studied earlier, sir, the graph of force and extension or the graph of force and length, you can calculate its gradient, and the gradient of graph is the spring constant. Okay, so I am calculating gradient. And how can we calculate gradient? What is the starting point? Sir, starting point x coordinate is 0 and y coordinate is 150 millimeter. It is x1 y1. And what is the second coordinate? Sir, second coordinate, x coordinate is 90 and y coordinate is 148 exponent minus 3. And now you have to calculate gradient, and gradient will be, हाँ beta, because it is in millimeter beta, it is in millimeter. Okay, so I am taking this coordinate is in millimeter. And now we are calculating y2, y2 minus y1, y2 minus y1, and millimeter I am writing one time, y2 minus y1 millimeter divided by x2 minus x1. So if I divide 148 minus 150, the answer is 2, and this 2 is divided by 90, so it is the answer. And this answer, it is known as a spring constant. Okay, but at 2 millimeter divided by 90, so the answer is 2.22 exponent minus 4. 2.22 exponent minus 4. It is the value of k. It is the value of k. And now the next part, they are asking determine strain energy. And as I taught you, if the graph is a straight line, then you can calculate the area, and the area means strain energy, it means elastic potential energy, it means work done on the spring having same meaning. So you can calculate either area, or you can calculate by, or you can use formula. And the formula is half k x square, or you can use half fx. So force is 90 kilonewton. Kilonewton, kilo means plus 3. And what is compression? So the compression is 150 is the starting point, 148 is the final point. So the compression is 2 millimeter. 2 millimeter. So if you solve it, then the answer will be 2 cancel out with 2, and this cancel with this. So strain energy will be 90 joule. Okay, but energy will be 90 joule. But the last part of the question, it is so difficult. I will explain you tomorrow, because this is a very difficult concept, and this it is our first class of deformation, so I should not confuse you in this part. In the first class, we should only practice the formula. And this is a very difficult question, and it is my promise we will solve this question tomorrow. And now the fourth question, define stress. What is stress? Sir, stress is force per unit area. Force per unit area. It is called stress. And what is a strain? Sir, a strain is extension per unit original length. Extension per unit original length. So stress, force per unit area, strain, extension per unit original length. And now this is another question. The question is, you are given a wire and the wire having cross-sectional area 9.4 exponent minus 8. The length is 2.5 meter. And this is a question about experiment. And the question is, how can you measure the area of wire? So if you have practiced, if you have done an experiment about screw gauge, then you can write its proper answer. Otherwise, it is very difficult to explain what is a screw gauge and how do we use it. So you should, if you have done practical, if you have done lab, then you should know what is a screw gauge. And now the next part, determine the young modulus. Now you have to calculate young modulus. So let's start to calculate young modulus. How about a young modulus? I am solving at the top of the page. Sir, young modulus denoted by capital E, and young modulus is force per unit area, extension per unit length. So we are calculating young modulus from this graph, and from the graph I can pick the values of force and extension. What is force? Sir, force value is 4 and extension value is 0.8. So I am using the value of force 4 Newton and the extension I am using 0.8 millimeter, and milli means exponent minus 3. Milli means exponent minus 3. So force is 4 Newton, extension is 0.8 millimeter, and then I need further values. I need length. Length of the wire is 2.5 meter. Length of the wire is 2.5 meter. And area is 9.4. Exponent minus 8. So now you can solve extension. Now you can solve extension. Sorry, you can solve young modulus. E is not extension, sorry. E is young modulus. Actually, E is modulus of elasticity. E for elasticity. So young modulus is denoted by capital E. So we have calculated young modulus. Young modulus is force per unit area, extension per unit length. So we have calculated young modulus. And now they are asking, calculate increase in energy stored in the wire when the load increase from 2 Newton to 4 Newton. From 2 Newton to 4 Newton, okay? So 2 Newton is here and 4 Newton is here. So we will calculate area. And remember, to calculate area of deformation chapter, there must be extension axis in the shape of graph. Sometime extension is along x-axis and sometime extension is along y-axis. So remember, we calculate area with the side base of extension. So for 2 Newton force, extension is 0.4. For 4 Newton force, extension is 0.8. So I am erasing that region, and now you have to calculate area of this region. We will calculate area of this region. Why? Because we calculate area with the base of extension axis. We will calculate area with the base of extension axis. In this question, extension is along x-axis. So I am taking this trapezium. And now calculate its area. Okay, now calculate its area. हाँ बेटा, can someone tell me what is the formula to calculate area of trapezium beta? Area of trapezium is half A plus B into H. And what is AB? Sir, A and B are length of parallel sides. Length of parallel sides. So half is constant. And what is the length of parallel sides? So this side is 2 Newton plus this side is 4 Newton. And what is the distance between them? So the distance between them is zero point 0.4 millimeter. It is zero point 0.4 millimeter, and millimeter means exponent minus 3. Millimeter means exponent minus 3. So 4 plus 2 it makes 6. 6 divided by 2 it makes 3. 3 multiplied with 1 0 0.4 it makes 1.2. So this is the energy. 1.2 exponent minus 3. It is the energy which is stored by this wire. When you are increasing force from 2 Newton to 4 Newton, the wire is storing energy, and the quantity of energy is 1.2 exponent minus 3. 1.2 exponent minus 3. But have you noted? Okay, beta. So by calculating gradient, you can calculate spring constant. By calculating area, you can calculate energy. And this part is also of same type. As I promised, we will solve this part tomorrow. And in the same way, we will solve this part tomorrow because both parts are of the same type. And now the next question is question number 5, and it is also not about deformation chapter. It is a question of upthrust, pressure difference. Upthrust, pressure difference, and your teacher is using very odd sequence of chapters. So what can I do? Because deformation chapter is taught by upthrust and pressure chapter, but you have not studied pressure and upthrust, and we are solving directly deformation chapter. So let's start next question. The next question, question number 6, define strain. What is the definition of strain? Sir, we have studied in the last part. Strain is extension per unit original length. Extension per unit original length. Okay. And now the question is here. The question is, a wire is designed to ensure that strain does not exceed. Actually, it is the value of strain. It is the value of strain. When a force of 8 kilonewton is applied, the Young modulus, the value of Young modulus is given 2.1 exponent 11 Pascal, and it may be assumed that the wire obeys Hooke's law. Okay. And now they are asking calculate stress. They are asking calculate stress. You know that stress over strain equal to Young modulus, or stress equal to the product of strain and Young modulus. Having same meaning, as I stated, stress is denoted by this symbol, strain is denoted by this symbol, and Young modulus denoted by capital E. The strain value is given. The strain value is given 4 exponent minus 4. It is the value of strain. And what is the value of Young modulus? Young modulus is 2.1 exponent 11. So by product you can calculate stress. You can calculate stress. So 4 exponent minus 4 multiplied 2.1 exponent 11. So it is stress. Stress is 8.4 exponent 7. And after calculating stress, they are asking area. They are asking area. You know that stress equal to force per unit area. If you have to calculate area, then area equal to force per unit stress. Force value is given. Force value is given 8 kilonewton. The value of stress is given 8.4 exponent 7. And by dividing, you can calculate area. By dividing, you can calculate area. By dividing, you can calculate area. So this class is only about formula practice. This is very simple formula practice question class. But when you will solve P1 question, oh, then you will find what is deformation chapter. But in P2, it is very simple. You are given simple values and you are putting the values and getting the answer. And now it is the next question on your screen. And in this question, May, June 2017, the question is the length of wire from C to marker is 3.50 meter. Actually, it is the length. Length is 3.5. The diameter, it is the diameter of the wire. You are given length, you are given diameter. And they are asking, use the gradient, determine Young modulus. Okay. So first calculate gradient. First calculate gradient. And sir, how can we calculate gradient? Sir, take 2 points on the line, and I think this point is very good point in which this is 20, and I think this is between 6 and 8. So we can take this point as 7. So x coordinate is 7 and y coordinate is 20. And you can take another point on the line, and I think another point on the line, you can take this point for which x coordinate is 4 and y coordinate is 8. Okay, so you can calculate its gradient. And gradient, I am writing gradient capital G. Gradient is y2 minus y1 and x2 minus x1. So 20 minus 8, it is 12, and 7 minus 4, it is 3, and along x-axis it is in millimeter, so I should write exponent minus 3 as well. I should write exponent minus 3 as well. So if you calculate this one, 12 divided by 3 exponent minus 3, so the answer is 4000. Gradient is 4000. Gradient is 4000, and this gradient means f upon x. F y-axis, x x-axis, so it is force upon extension. It is force upon extension, and you have to calculate Young modulus. Then you know that Young modulus is force per unit area, force per unit area, extension per unit length. Then this F upon X is gradient. This F upon X is gradient, and its value is 4000. F upon X is gradient, and gradient is 4000. The length of wire is 3.5, and area is not given. You are given diameter, and you know the diameter is pi d square upon 4. Okay, so f upon x is gradient, length is 3.5 meter, and area can be calculated by pi d square upon 4. So by calculating these number, you can calculate Young modulus. You can calculate Young modulus. Okay beta, so I am stopping recording.